Hello and welcome to T1 Day 15 of Honors Precalculus. Today we're going to talk about polynomial and rational inequalities. So first we're going to write a set. So we're going to write a set of all numbers that is less than 6. So the first phrase is less than 6 or that's important, greater than or equal to negative, greater than or equal to negative 5 right there. So what you're doing here is you can visualize this by making a number line and doing the first statement. The first statement is less than 6. So you're going to go to 6 and it's going to be an open dot. It's less than, so it's less than 6. And then greater than or equal to negative 5. Switch over to green. Negative 5 will be, let's say right here, it's equal to, so it's going to be filled in, and then it goes to the right like that. So where do those things union? Because that's what or means. That means union. So if you added those two sets of numbers together, what do you get? Well, it covers the entire number line. So if you union these things, you're going to end up with negative infinity to infinity. You could also say all real numbers. Similarly, we could ask the same thing, but this time there's the and. So we again have all numbers that are less than 6, but then we have greater than or equal to negative 5. So again, we have the same number line. We have 6 and negative 5, and then we're going to have the open dot here going to the left, and we'll have a closed dot here going to the right. Where do they overlap? Meaning both are true at the same time. They're both true from here to here, inclusive of 5, but not of 6. So in this case, the answer is going to be, because it's and this means intersection, it's going to be inclusive of negative 5 up to but not including 6. So what do you do if you're given an inequality that's written as a quadratic? So we're solving each of the following inequalities for x, and write your answers in both inequality notation and interval notation. We'll do both here. So the first thing you're going to do is you're going to factor this, and this turns into x plus 2 times x minus 1 is greater than 0. What we're going to do is keep track of when is x plus 2 positive and when is it negative, and when is x minus 1 positive and when is it negative. And then we're going to use that to figure out when their product is positive and when it is negative. So where do these change sign? Well, it changes sign at negative 2 and it changes sign at 1. So what we're going to do is we're going to make a number line here, and we're going to say negative 2 and 1, little dots down like this, straight line. And then we ask ourselves, what is going on with negative 2 and with x minus 1, sorry. So if you plug in numbers to the left of negative 2, and I'll use blue here, same color. If you plug in numbers to the left of negative 2, what is the sign of this? So you plug in like negative 3, for example, this would be negative. So it's negative like this right there, and then it's 0. And then what about x minus 1? If you plug in negative 3 in here, it'll also be negative. What happens when you plug in a number that's between 1 and negative 2? Let's say we plugged in 0 and plug it into this region right here. From here, what is x plus 2 between those at 0? Well, it's going to be, it's sorry, it's going to be positive, because like 0 plus 2 is positive. It's going to be the same thing across. And then it'll be down below here at x minus 1. When you plug in 0, it's going to be negative right here. It's going to be negative. Okay, so what about what happens when you go to the right here, to the right of 1? Let's say we're plugging in 2. Well, this will be positive right here. X plus 2 will be positive. When you plug in 2 here, it'll also be positive. So you can use this to determine what is the sign of x plus 2 times x minus 1. You multiply these together. So if you multiply a negative and a negative, you get a positive. So it's positive all the way to here. Then it's 0. 0 right there. And then what happens when you plug in, when you multiply a positive and a negative, you get a negative in the middle there. And then you have a positive and a positive. So one way to write this, and remember when you plug in, you'll get 0 here, and when you plug in 1 into this, you'll get 0 right there. So one way to write this is x less than negative 2, or x is greater than 1. And it's or because if you graph this, you can kind of take a look. It's going to happen in either space. It's going to happen in either space. When you graph this quadratic, it crosses at negative 2 and it crosses at 1. It looks like this right here. You can kind of see where it's going to be positive. It's positive here and here. So that's the inequality notation, and the way you can do it in integral notation is negative infinity all the way up to -2, not inclusive because 0 is not positive, and then union of 1 to infinity. The key is to make this chart to carefully go about figuring out if it's positive or negative in each case. The only thing that changes here is we have to put everything on one side first, so it's going to be like this, and then you factor. So you get x minus 4, x plus 3, and then what are the numbers that cause sign changes? That's going to happen at 4 and -3. So you have -3 and 4. I like putting those dotted lines down here to do the divisions. And then what are the two factors? X minus 4 and x plus 3. And we have our regions to the left of -3, between the two numbers, and then to the right of the numbers. So we could plug in, I don't know, -4, 0, and let's say 5. If you plug in -4 here, it's definitely going to be negative across, and then you plug in 0, it's still going to be negative. But then when you plug in 5 into that, 5 minus 4 is going to be positive right here. Yay! And you know it's also going to be 0 right there. What about x plus 3? Well, if you plug in -4 into x plus 3, it will be negative, and then it'll be 0. And you plug in 0 into x plus 3, it'll be positive going across. Plug in 5 into x plus 3, it'll stay positive. But now you look at the product of those two things, looking down here. So what's the product of a negative and a negative? That's going to be a positive. Negative and a positive is a not positive. I got to be careful there. It's going to be 0 here, and then it's going to be negative. Then it'll be 0 there, and then positive and positive is positive. So what's that going to be? Well, it has to be less than 0 here. So this means and. Because it's less than, it's and. Before it was greater than, so it's or. So here it's x less than -3 and x, excuse me, might have caught a mistake there. We're going less than 0. So we're looking at where it's negative. Because it's less than 0, we want the part where it's negative. So where's that the case? Well, that's when x is greater than -3 and it's less than 4. Now it's equal to, so it will contain these two because there's the equal to as well. So then you would write that as an integral notation, -3 to 4 with closed brackets there. So because it's less than, it means and because it's equals, you know, it's closed brackets. So this one adds in a cubic term, and it puts two factors, two x's on each side, and x on each side. So you just got to put everything on one side first, put it in order. You get -4x minus 20 is greater than 0. So this means it's going to be an or. It's going to be outwards. And now we only have one way to factor cubics, which is using grouping. So we factor out an x squared, and we get x plus 5. Factor out a -4, and we get x plus 5, which is exactly what we want, because we want the same thing to be in both of those terms. So then we have x squared minus 4 coming into there from those two, and then you still have the x plus 5, but you're not quite done factoring, because this is factorable into x plus 2 times x minus 2, and then you still have the x plus 5. So the only thing that gets added in here on the number line is instead of 2 divisions, we have 3. We have a -2, 2, and -5. So we have -5, -2, and 2. So we have 3 areas right here, well 4. I like to put these little dotted lines down so you can kind of see what's going on. And then what are the factors? We have x plus 2, we have x minus 2, we have x plus 5. Let's say -6, let's say -3, plug in 0 and 3. So when you do this out and you plug in -6 here, you get negative right there. -3, it stays negative. 0 right there. Plug in 0, it becomes positive. And then plug in 3, it stays positive, like this. Plug in -2, it'll be negative. Plug in -3, it'll be negative. Plug in 0, it'll still be negative. Then it'll be 0 and turn to positive. Now we plug in 5, well, -6 into this one, and it's still negative. But then it's 0 here, and then it'll be -3 plus 5. It's going to be positive. 0 plus 5 is positive. And then it'll be positive. And then what about the product of them all? Meaning, sorry, I'm going to block that there for 1 second. What's the product of all of these things? Well, it's going to be the 3 of those, negative, 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 is negative, and then 0. Negative, negative, positive is going to be positive. 0 again. Negative and 2 positives is going to be negative. And then here it's going to be positive. So, pause. So now we need to do the union of 2 places. What are they going to be? Well, there's words positive there and there. So that would be when x is between negative 2 and negative 5, or when x is greater than 2. And we can write that as negative 5 to negative 2 union 2 or greater. And because it's not equal sign, we don't need brackets here. We should have regular open parentheses. So the next thing we can add in is a quotient, and you still do the same thing. You factor out the things you can factor out, and you end up with x plus 4 times x minus 4, and it's greater than or equal to 0. So this will be still an or statement because it's greater than, and you know it'll be brackets because there's the equal sign. Well, you still have these 3 numbers you need to use here. Those 3 numbers are what makes those highlighted parts 0, and those are going to be 3, negative 4, and 4. So we have negative 4, 3, and 4. This doesn't need to be to scale, but they need to be relatively the same order. So now you do the same thing. You look at x minus 3, x plus 4, and x minus 4, because dividing by a positive or negative has the same effect on sign as multiplication. So let's do, I don't know, negative 5, 0, and this one's tricky, it'd be like 3.5 here, and then 5, because you have to go between 3 and 4 right there. So what happens here? Plug in negative 5, it's going to be negative here, and then it'll be negative, and then it'll be 0 right here, and then it'll be positive, and then it'll be positive. So if you fill in the rest of this, you have to be careful, because now when these are in the denominator, when it's equal to negative 4 on this, it'll be undefined right here. It'll be undefined. You have to be careful. Plug in negative 5, it'll be negative and then undefined. Plug in 0, it'll be positive right here. And then, well, the term itself, to be more accurate, would be 0. The term would be 0. We'll get to the undefined in a second. When you plug in 3 into x plus 4, it's still positive. And when you plug in 4, it's still positive. What about x minus 4 when you plug in negative 5? It'll be negative, and then it'll be negative, and it'll be negative, 0, and then positive. But now when you do this whole thing, the division here, what's going on here? You have to be really careful. It's very similar. You do this, like this will be a negative over a negative times a negative. So what do you end up with? You have to be really, really, really careful here. You can think of it as multiplying. It will be negative. But then here's the thing, when you're dividing by this now, this will be undefined. So what does this come out to be? This would be undefined at negative 4. And then between the two, you've got negative over the product of these two, negative over the product of those two. It's going to be positive this time. And then it would be, it would plug in 3, it'd be 0. And then if you do this one, it'd be positive divided by the product of those two things. It's going to be negative now, but then it's going to be undefined because you can't plug in 4 into there, and then it's going to be positive. So where is this greater than 0? It's greater than 0 there or there. So what do we end up with? X is between 3 and negative 4, or that's a bad or right there, x is greater than 4. So how do we go about doing this? Since it's equal to, you can be 0 right there. It'd be equal to right there. That's an or. So how do you write this in interval notation? Negative 4 to 3. It's an open parenthesis there, and then closed, union, and then open 4 to infinity. So you have to do this out pretty carefully. Remember, it's undefined right here and right here because you're dividing now by those two terms. So this one's very similar to the last. We have to combine everything into one fraction. So for example, we have our x minus 1, and then 1 right here. So if we want to get a common denominator, we're going to have to multiply. If you want to do this, you have to get a common denominator. So for example, 4, you could multiply by x times x minus 1 over x times x minus 1. That's a form of 1. So what is that going to turn into? 4 times x minus 1. And then you end up over x times x minus 1. And then what do you multiply the second term by? You multiply the second term by x minus 1 over x minus 1. And you get 2 times x minus 1 over x times x minus 1. Okay? And then this 3 right here, 3 over that, you have to multiply by x over x. So you have less than or equal to 3x over x times x minus 1. Now we have the same denominator. We can put everything on the same side and combine. So what does that mean we end up having? 4 times x minus 1 plus 2 times x minus 1. We're subtracting that, minus 3x, over, it's all the same denominator, and now you're left with 0 right there. Now you need to simplify and then factor the numerator. When you do this out, you end up with 4x squared minus 4x plus 2x minus 2. That's all of this multiplication right there, minus 3x over the same denominator right there, less than or equal to 0. Now we group things together that are the same, so you got these grouped together and this one right here. So you end up with, I caught one mistake right here, that's a minus sign right there. So this should actually be a minus right there. This should be a minus. So this should be a, right here, a minus 2x and a plus 2 right there. Small mistake. So now when you combine these terms right here, you're going to end up with 4x squared minus 9x plus 2 over x times x minus 1 less than or equal to 0. And now you factor that numerator, and it might take you a little bit, but it is 4x minus 1 and x minus 2 all over x times x minus 1 is less than or equal to 0. Now this means it's going to be an and it's going to get a look at that equal sign as well. So when you fill out the chart, there's going to be the number that makes these 4 things 0. And those are 1/4, 2, 0, and 1. So if you put those in order, and doesn't have to be to scale, they just have to be in the relative right order here. You have 0, you have 1/4, you have 1, and you have 2. And what you're filling out here is the first term. You could say 4x minus 1 is the first one, and then you have x minus 2, x minus 1, and x. And you're looking at it for these regions here. 2, 0, between 0 and 1/4, 2, 1, 2, and then greater than that. When you fill this in for these right here, when you fill this in, I'm not going to do it one at a time, I'll just fill it out for you. You ended up with something like this. And now you have to look at what happens when you plug all these factors in together. So for example, it's the product of these two divided by the product of those two. So what's that going to end up being? A positive divided by a positive is a positive. And then it turns out to be, so right here when you plug in 0, you can't plug in 0, so it's undefined right there. You can't plug in 0 because of that term. And then if you do the next bit of it, it's going to be the product of these two divided by the product of these two. So it's a positive divided by a negative is going to be a negative all the way from here to here. And then it's going to be 0 right there. And then you have a negative product and a negative. So a negative divided by a negative is a positive right here. And then it's 0 because you can't plug in this, so it's undefined right there. And then from 1 to 2, you have this product is negative divided by a positive, and negative divided by a positive is a negative. And then it's 0 because you can plug in 2. And then after that, it's all positive. So where is this negative? It's negative here, and it's negative there. So that is between, it's less than or equal to 1/4 and greater than 0, can't be 0. And then it's also from, can't be 1, so it's going to be x less, it's going to be greater than 1. That's a bent 1 right there. I'll clean that up. And it's going to be less than or equal to 2, because it can be 0. Remember, it can be 0. So what would that be in interval notation? 0 all the way up to 1/4 inclusive, union, not including 1 all the way to 2 closed. This just takes practice. This just takes practice, but do it out carefully. Think about it logically.